That is why people who study precise science in universities got more wild horizons than mine. Is it clear? Well, and I would like to give you also insight what does mathematical language means. Don't be scared, and just simple example. Because what I'm going to explain to you now, it's not real mathematics, just mathematical language. It's like alphabet, you know, before starting reading things, before studying literature, before studying poetry, you study alphabet, right? Because without alphabet, you're not able to do any literature. That is why in mathematics they got own alphabet. And if you would write mathematics in plain English, let's say, it would be not convenient. It would be a lot of faults and you would lose mathematical idea. That is why I will give you example how mathematicians write their things. So you did study mathematics, right? Already, little bit. You know what function means? Who know what function means? Function. No idea. Okay, I give you a little bit description just for the sake of demonstration of mathematical language. Function is any kind of you could name it, you could imagine this as a black box. You put something in the black box, some numbers, and take out another numbers, output, input, output. So this is your black box, your function. So you put some numbers here, and these numbers will be usually x. This is letter, which means it could be any number. You put something in this black box, and in output you get a number, another number. We write it fx. F means that we operate something on x. That is why x is here. So f, or you can write is equal to some y. So y dependent on x. X your petrol here, y let's say speed of your bike. Right? This is also a function. This is also a function. So let's function could be expressed graphically. So this is your x, this is your y. To any x corresponds something y, some y. So your graph would be like that, for example. So for any x corresponds some fx. Is it clear? It's quite easy. It's very natural way to express your functions. And later, mathematicians introduce notion of limit. Let's say we got a particular point, a here. So this is x equal a. And we would like to see what is meaning of your function when x approaches a. X approaches a. How to express this in mathematical language? If I would express it in plain English, I would say this. Let's take some neighborhood of this a. When x approaches a, as soon as x enters some close enough to a, then fx, what is fx? So this is fa. This is meaning of your function at this particular point, right? As soon as x comes close enough to a, what happens? We got corresponding neighborhood for fx. It will be here. So for this neighborhood of x, we got corresponding neighborhood for fx. In plain English, it would be expressed like that. sorry, I don't want to be tedious. It's just example. Okay, it's not really complicated. In plain English, if x close enough to a, fx close enough to fa. But what does it mean close enough, close not enough? It's not really strict. And mathematicians didn't write own language to express this. Precise and concise. But first, I will demonstrate how they do it. This is mostly in Russian school of mathematics. They do use these symbols. These symbols mean any, only to one. And this symbol mean exist. Any exists. We could write it in plain English, but we can use these two symbols. It's not complicated. Just make our notice a little bit more short. How to now define notion of limit in mathematical language? You cannot remember it, I just demonstration. In mathematical language, what limit means? Limit, we mean lim is lim. Below we write when x approaches some point A. X approaches some point A. Limit of what? Limit of our function fx equal to what? Equal to fa. So meaning of our function at point, at particular point. What we use to find limit. Now we need to define limit. Once again, in plain English, it sounds like that. And then you compare two different notions, in plain English and in mathematical language. I would say in plain English, I would say when x comes close enough to point A, fx close enough to point fa. But this is poetry, this is not mathematics. In mathematics, we write the following. For any epsilon more than 0, later I explain what it means. Exists some delta more than 0, such that modular of difference fx, fa minus fx less than epsilon. Whenever modular of difference x and a less than delta. This is definition of limit. Of limit in mathematical language. And now I give you insight of this. What does it mean? What does it mean? What is epsilon and what is delta? As a matter of fact, epsilon delta is abstraction. This is kind of number as small as you can imagine, but still positive. So it's 1 divided by 100 millions, but still smaller. Or you can say 1 divided by 1,000 billions, but still smaller. So this is abstraction, as small positive number as you can imagine. And what is here? For any epsilon as small as you can imagine, exists corresponding data. This is also another number as small as you can imagine. But for any epsilon, and epsilon delta dependent, for any epsilon, you can find out some delta. So as soon as fx minus fa, as our fx come to some neighborhood, epsilon neighborhood, let's say here, epsilon neighborhood of fa. So immediately for this corresponding neighborhood, we can find exist some delta here. So as soon as x enter delta neighborhood of A, immediately fx enter epsilon neighborhood of fa. Maybe for some of you it seems to be difficult, but this is, as a matter of fact, this is not. This is not even mathematics, this is mathematical language. And I demonstrated use this example just to understand why students got difficulties in mathematics, even when mathematics is not difficult itself. Because of this abstraction. Because you need to get used to it, what happens. It's like studying foreign language. Let's say you study Chinese language. First you totally miss this hieroglyph. It's abracadabra, you will not understand the word. But when you started to understand what this hieroglyph means, slowly, word by word, you started to understand what these Chinese people are talking about, right? Or French people, or Italian people. Same thing is also. But despite some precise language, mathematical language is universal. It's united mathematicians of all nations. That is why when mathematicians come to conference, any mathematician from any country able to understand each other, because all of them using the same mathematical language. This is universal language of science. And it is a big advantage to use your studies here in English. I appreciate that. Because nowadays, it happens historically that all conferences, all significant magazines, all significant books are written in English. And people of other countries, French people, Russian people, Chinese people, should study English language first if they want to do international science. You got your language from school. It's more advantage these days. Sorry for this example, just want to demonstrate you how does it work. How it works like. How it works in reality. Don't be scared of this. Never be scared. If you want to achieve something, you need to get some kind of intellectual figure. And if you think about this, it's actually amazing why mathematics became so successful. Because in mathematics, we can describe a lot of things in physical world which happens around us. And mathematicians very often use together with physicians. How? For example, physicians discovered in their experiments something new in nuclear physics or whatever. And they come to mathematicians. Please give us language to describe this. And then mathematicians can set the decisions. They can invent some abstract language, abstract notions, abstract equations to describe, to understand this physical model. When this model, but any physical model, little just approximation, when this model stops to work or begin to root for some particular tasks, physicians want more sophisticated models. This happened with mechanics. Maybe you didn't study yet, but you will study for sure in physics. First, it was mechanics from nucleic physics. It was very simple mechanics, and then it was laws of Newton. And mathematicians gave formulas for this. First law of Newton, second law of Newton, and so forth. But later, when people started to study nuclear physics, they found it out that laws of Euclidean mechanics doesn't work when you go to atoms. It's very small. So you need quantum mechanics. It's totally different with own law. And that is why mathematicians did search the physicians one more time. And it was special mathematics for quantum mechanics. It's a little bit more advanced, more sophisticated stuff. And so forth. Same happens with Euclidean geometry. One of the postulates of Euclidean geometry is that if you put some line, it came from ancient Greece. When you put some line, let's say on plane, and some point outside, there is only one line which can pass through this point and be parallel to this line. Right? Only one. Any other lines from this point, at some point, this point will be very, very far away, thousand kilometers away, but still it will be intersection. And only one line never intersects this line. It's like railways, yes? These two lines never intersect each other because they are parallel. They are parallel. And this was okay with Euclidean geometry. But later, another geometry was invented. Geometry of Lobachevsky, or Riemann geometry. And in those geometries, there are infinitely many lines to this point which could be parallel to this line. It could not be imagined by ancient people, but it appeared to be very useful for modern sciences. Later, they started to study, let's say, geometry of sphere. So it was not just a plane disk, but everything happens on sphere. So on sphere, there are a lot of points, a lot of lines on here, a lot of lines on here. This is totally different geometry with all mathematics. All mathematics. And what else I want to mention? That you think that mathematics is strict science, right? Precise and strict. But as a matter of fact, this is not not really like that. Because mathematics based on some axioms and some undefined meanings. One of them not defined meaning is set. What is set? Collection of some elements. That set of points. It's something that you got. You cannot define it. You already have to go to opposites, right? Later, it was axioms. What is axiom? What axiom mean? What difference between axiom and theorem? Theorem you should prove. You have said something, you will prove this, whether it's true or not. But axiom, something that you take without proving. Like in Euclidean geometry, they take this axiom that through a point which doesn't belong to line, there is only one line which parallel to your line. This is axiom, no need to prove it. It's given by God, let's say. Later, scientists became more sophisticated and they decided why we should use this set of axioms. What happens if we take another set of axioms? We can then create another mathematics. And in this sense, from this point of view, mathematics not as strict as it seems to be in the first place. I give you an example. It's kind of level mathematics. It's axiom of separation. I'm not going to go deep inside to explain what does it mean. It doesn't matter. But some mathematicians in modern form accept this lemma, axiom of separation. Lemma. Some mathematicians think that this is bad-based, this doesn't work. And then funny thing, in some conferences, sometimes when some mathematician in this report mention lemma, some mathematician can stand up and leave because they think this is not serious. It's not mathematics. This guy is not serious. It still happens like that. So mathematics in highest level could be quite sophisticated. But of course, no one demands of you go to such full scientific. When you go to study to basic level, and I just would like to warn you, don't be scared and don't start crying. Because nowadays, in your smartphone, any formula, any theory, you can get it in a few seconds. It's not the point to remember all these formulas. It should come naturally inside you. Why you should study, let's say, mathematics in school, university with professors? You can get everything on YouTube, you can get it. But maybe in school, universities, they will help you to understand. The most important when you study mathematics, you should keep your interest. You should take it as a game. You should understand why your professor, why a book introduced this theory, where it came from, what's the reason for that. Why it's necessary to introduce this theory, this formula? What besides this formula? What meaning of this formula? And when you come study mathematics from this point of view, it's never became mathematical. Understand? Keep your interest. Take it as a game. Try to go inside. Try to have fun. If you're having fun, if you're having your interest, you never stop crying. And even if you, let's assume that you started crying, you remember some formulas without understanding where it came from. You got on your exam, you got task. Solve this problem. Even if you know right formulas which fits for this particular task, you will not be able to use it because you didn't understand where it came from, how it works, how it can be used. If a little bit not standard task, it totally works. Yes. I see a lot of smart faces, so I think it's doing good. And this actually related not only to mathematics. Maybe you, in your own experience, you noted that if something is interesting, it's easy to do. If something not interesting, it became boring. You don't want to do this. It's torture for you, right? It wastes time. Let it go for every day. Right? That is why keep interest, and develop your capabilities, develop your talents. Not all of you go to be mathematicians, but to understand mathematics at school level, it's absolutely necessary. Absolutely necessary. You know, I've been in war quite recently, and sometimes people must using calculators to add two simple numbers. I think that modern students should be more honest. Well, another reason I would like to tell you about some people who make this lecture because invest more after this people who do mathematics usually. My experience is smart and interesting people. I met mathematicians from different countries. Usually, these people are interested in what they're doing. Some of them work in universities, teach students. But mathematics got a lot of applications. Nowadays, mathematical knowledge is very high demand. When you finish your school and university, you will be in the job market. And confidence in the job market very high. Very, very high. To get good place and get good salary, you need to be on top. You need to be able to do something really real and something sophisticated. And mathematics now in high demand presents a lot of data, big data projects. So you need to do something with this big data. The only one instrument to understand big data is mathematics. So you can do statistics, you can build some mathematical model. What does it mean, mathematical model? You get some, let's say, set of points. To extract some information from this set of points, a lot of numbers, you need to create some structure of these numbers. And as soon as you did this, you will be able to work with this data, to get some knowledge from this data. It's not only already complex of data, millions of numbers, meaningless numbers. You will be able to catch these numbers and extract useful information. So big data is one area of applications. Another area of applications is mathematics, artificial intelligence. This network is very robotics, which is very popular nowadays. My instrument here also mathematics. Engineering, mathematics. Even in humanitarian sciences, when they study poetry, sometimes they use mathematics to understand how poetry is organized. One of my friends, after finishing mathematical faculty of university, went for his PhD to humanitarian philological faculty. He did use mathematics for understanding poetry, like that. So, a lot of applications. But once again, if you would like to come into life, not with mathematics, but